8.4, solving trig equations by factoring. So this is our second day of solving trig equations, and today all of our equations will be in quadratic form. So when we think of quadratic form, that looks like ax squared plus bx plus c equals to 0. And when we learned early in the year about solving quadratics, we had a few methods. So one of the methods was solving by the square root property, which we're going to do today, factoring, which we will have examples with that, and quadratic formula. And we'll do one example like that. We'll be using our exact value table, your calculator, as well as this chart that talks about in which quadrants the trig ratios are positive and negative. So type 1, solving the square root property. So we use the square root property when we don't have a b term, when we're in the form ax squared plus bx plus c. So you'll notice we just have a cosine squared. We don't cosine squared theta. We don't have a cosine theta. So I'm going to solve this by using the square root property. First thing that I notice is my looking for angles between 0 and 360 degrees, so I know my answers will be in degrees. So my answers will be in degrees. First thing I want to do is get the cosine squared by itself. So I'm going to rewrite this. So I have 8 cosine squared theta plus 3 equals 7. I want to get the cosine squared by itself. Oops. So I'm isolating that. So I'm going to subtract 3 and divide by 8. So I end up with cosine squared theta equals 1 over 2. Now it's cosine squared theta, so I'm going to take the square root of both sides. I can't forget the plus and minus. That's really important because that's going to give us 2 more solutions, so don't forget the plus and minus. So a square root of cosine squared is going to give me cosine theta. I'm going to rationalize the denominator here, and I'm going to get cosine theta is equal to plus or minus radical 2 over 2. So the plus and minus is really important. If you forget that, you're going to only end up with 2 solutions. And in this case, we have 4 solutions. So first thing I'm going to do is check to see is radical 2 over 2 in my exact values table. So cosine of radical 2 over 2 is in my exact values table. I have a reference angle of 45 degrees. So my reference angle is going to be 45 degrees. So this is in my exact value table. Then we have to think about which quadrants our solutions are in. Since I have the plus and minus, if I look over here, I need to know when is cosine positive and when is cosine negative. So I'm going to have my answers in all 4 quadrants. So cosine is positive in quadrant 1 and quadrant 4. And cosine is negative in quadrant 2 and quadrant 3. So now we have all the information we need to come up with our solutions. So we'll state our solutions. So in quadrant 1, my solution is just going to be the reference angle, or 45 degrees. Quadrant 2, I'm going to be 180 minus 45, or 135. Quadrant 3, 180 plus 45, or 225. And then quadrant 4, I'm going to have 360 minus 45, or 315. So I have 4 solutions here, one in the first quadrant, second quadrant, third quadrant, and fourth quadrant. And that's because of that plus minus. We'll do example 2 here, which is also using the square root property. On example 2, we'll notice that our answers need to be in radians because my range is given in radians. I have my charts that I'll use if I need them. I'm going to, we're going to rewrite this into get my cosecant squared by itself. So I'm going to start with 6 cosecant squared x minus 10 equals 4 cosecant squared x plus 3. I'm going to subtract 4 cosecant, so I will get 2 cosecant squared x minus 10 equals 3. I'm trying to get the cosecant squared by itself. I'll move the 10 over. So I'm going to have 2 cosecant squared x equals 13. Divide by 2. I get cosecant squared x equals 13 over 2. I'm going to take the square root of both sides. When I take the square root of both sides, I need to remember the plus or minus. So don't forget that, because then you'll lose 2 of your solutions. So now I'm going to be solving cosecant x is equal to plus or minus. I could go ahead and rationalize that. So I'm going to get plus or minus radical 26 over 2. That is not in my exact values chart. So I'm going to go ahead. I'm going to use my calculator here. And I need my answer in radians, so I need to be in radian mode. And since I'm looking for the angle, we don't have a cosecant button on our calculator, so we're going to go ahead and think of this in terms of sine. So I'm going to go ahead and write this as sine inverse. Well, actually, let's do it like this. We'll say sine of x is equal to plus or minus 2 radical 26. Really doesn't matter if we're rationalized here, because we're just going to plug this into our calculator. So I'm going to plug into my calculator sine inverse 2 over radical 26. We want to plug the positive in because we want to have a first quadrant reference angle. So if I plug that, first I'm going to make sure my calculator is in radians. I am in degrees, so I'm going to switch it to radians. I'm going to plug in sine inverse 2 divided by radical 26. And that gives me 0.4030. So I'll do 0.403 radians. So now I have my reference angle. Let's kind of lay out what we have. We have our reference angle is 0.403. I need to think about what quadrants. So when I think of cosecant and sine, we want to think, where are they positive and where are they negative? So if we look up here, we're going to be in all 4 quadrants. So cosecant is positive in quadrant 1 and 2, and it's negative in quadrant 3 and 4. So we're positive in quadrant 1 and quadrant 2, and negative in quadrant 3 and quadrant 4. So now we're ready to come up with our solutions. We have our reference angle and radians. We know which quadrants our solutions are in, so we can now come up with our solutions. So my solutions. My quadrant 1 solution is just going to be my reference angle. My quadrant 2 solution is going to be pi minus 0.403. So if I do that on my calculator, I'm going to get 2.73. My quadrant 3 is going to be pi plus 4.403. So pi plus 0.403 is going to give me 3.54. And finally, my quadrant 4 solution is going to be 2 pi minus 0.403. So 2 pi minus 0.403 gives me 5.88 radians. So I have 4 solutions here. That's why it's really important that you use your plus and minus so you don't miss 2 of those solutions.